and together with the School of Natural Resources, we are presenting this series on renewable electricity and what that means in a state like Nebraska. There have been 3 lectures previously. This is the last one this year. I think we've been really pleased with the results, and so I'm hopeful that we'll be able to do something like this again next year. The topics will be very much dependent on what's happening in the legislature and what policy issues are most under debate. But since we started this series in February, there really is a lot that has happened here in Nebraska. The Energy Office has released a new renewable energy plan. The Natural Resources Committee of the unicameral has announced an interim study on renewable energy. And every senator who is seated in the Natural Resources Committee has opted into the study committee, which is, I can't remember a time that's ever happened before. The mayor has launched a greener, cleaner energy with renewable energy and sustainable components. And the federal economic stimulus constituted the largest investment in clean energy in the world to date. The passage of the 2010 budget demonstrates that we believe that clean energy is in fact a national priority. You may have seen in our announcements that there's quite a debate about back and forth between do we need more coal and do we need more wind, and what exactly is the right place to go from here. A couple of weeks ago, Federal Energy Regulatory Commissioner John Willinghoff stated that the United States may not need to produce new coal and newer nuclear power plants ever. Days later, other energy experts said otherwise. James Schlesinger, who was founder of the National Renewable Energy Lab under Ronald Reagan, said, we expect the lights to go on when we flip a switch, and we do not expect our computers to shut down as nature dictates. Solar and wind energy are available only part of the time, and consumers demand power. So that's some pretty broad opinions being voiced on this subject. Tonight we have an expert with us who I think is going to address one of the key issues in providing renewable wind from intermittent sources, and that is how do we integrate this source into the grid and into the system. Bob Zavadil is responsible for developing and overseeing the Internex Corporation's power system engineering and consulting business. Bob's a nationally recognized expert in electric power systems issues for wind generation and wind integration. His clients in the industry range from turbine designers and manufacturers to project developers, along with Nebraska Public Power District and utilities right there in the state. He has over 20 years experience with advanced modeling and simulation for power systems, which are key in trying to figure out how this is all going to work. So, we are very, very pleased to have Bob Zavadil here with us tonight. I hope the lights don't go off in the middle of the lecture. I trust they won't.
I'm sure it'd be because of that wind.
Yeah. I'll turn it over to you.
Okay. Thank you, Mary. A few items of housekeeping here before we get started. In the interest of full disclosure, I'm actually an ex-Nebraskan. I was at Nebraska Public Power District in the 80s. In the interest of even more disclosure, I'm actually an acquaintance of Gary Thompson, so you can take that however you want. With Internex Corporation, we're in Knoxville, Tennessee. Another sort of current events that you folks might be interested in is that the volunteer fans can't wait for the Kiffins to get started. They are bowing at the altar of Kiffin, and I guess we'll have to wait till fall to see how that works out. But there's been a lot of stories in the newspaper about the Kiffins, especially Monty and his Nebraska roots. So we're talking about you down there. This evening, we're going to talk about wind energy, obviously, and how it fits into the larger electric energy supply picture. A lot of people do think it's a square peg in a round hole. In some senses, though, the fit may be really dependent upon the lens through which you're looking. It doesn't fit when we look at electric power supply from sort of the older view when electric utilities were vertically integrated monopolies. But as we look forward and look at things a little bit differently, still take care of the important things with regard to reliability, one can see that fit maybe isn't quite as poor as we thought. I've been working in wind since '89. The first 6 or 7 years of that were sort of imagining the challenges that would arise if wind ever took off. For the last probably 12 years, we don't have to imagine. There's been a whole host of sort of first-time problems that the industry's had to work through. And if you're close enough to this, what you really see is that the wind energy industry is maturing. I mean, it's not a novelty anymore. It's actually in the maturing process. A lot of the focus in the industry is building the business, supply chain, all those sorts of things are what are being worked on. And that's in anticipation of an opportunity to exponentially grow from where things are at right now. To get that to happen, though, there's a lot of pieces that have to come together. And if we take the electric utility view of the world, the pieces and parts, nuts and bolts, in terms of the standards and the details of interconnection and those sorts of things need to be addressed. It's been, as an electrical engineer, I've been in this business for 30 years, there's been nothing as interesting as wind. Okay, because wind has, in some sense, caused us to sort of re-examine how we've looked at almost any problem previously, and then get back to the technical basics and say, okay, what are we trying to accomplish here and go forward. So just from an academic standpoint, almost that's been very, very interesting, and we've made a lot of progress in the last 7 or 8 years. There are a large number of people within the electric power industry today that are now working on problems related to wind. 7 or 8 years ago, that wasn't the case. So we're getting there, but we have a lot to do. I bring that up because if you take a step outside the industry and you hear people talking on TV that aren't necessarily armed with all the facts and stuff, you hear huge subsidies and these sorts of things. And there's sometimes a kernel of truth in that, but it's spun, okay, sometimes unintentionally, and it comes off wrong. So we're going to talk about some of those things tonight so that we're all on the same page. I think that the takeaway, though, is that we've got a lot to do, both the wind and the power industries, if this is going to continue. There's some significant challenges ahead. Wind energy technology has been around for a long time. Folks in Nebraska know that. We've used windmills forever. It goes back hundreds of years. We're just doing it in a little grander fashion these days, where a wind power plant is dozens or hundreds of individual turbines that are put together in a fashion and connected to the bulk electricity transportation system, transmission. But the scale is still impressive. This is I think it's the 3.6 megawatt turbine from GE, which is intended for offshore applications. And to really look at that picture is amazing. And I think you folks are developing some sense in this part of the country, because if you drive the interstates, you'll see towers going down the interstate. You'll see blades on trailers. And if you look closely, you'll see those gooseneck trailers are designed very carefully, because we have interstate overpass clearances, right? And trying to fit these big pieces and parts into our transportation infrastructure is a real challenge. So if you ever get a chance to actually walk up to a turbine as opposed to driving by on the highway, you have to do it. Because seeing the pieces and parts still doesn't give you the best sense of just how big these things are. Wind energy is the fastest growing form of electric generation on the planet. Okay, it's been that way for a few years. In 2008, the U.S. wind industry installed almost 8,000 megawatts of new capacity.